Hello and welcome to my YouTube channel. You're probably coming from my Tindie page. If not, I recommend you to go there, you will learn more about what I'm going to talk here. Today I will review with you the Luciole RGB dev board. The smarters of you notice that the name is French, and that mainly because I'm French, so please forgive my poor English. Anyway, this module is an RGB LED controller based on the ESP8266. This board can be programmed through the micro USB here and powered in 12V through the 12V plug over there. The shape of the board is made to have the 12V plug on one side and the RGB LED header on the other. Despite of the size, the board shape is made to ease its use in real application. This is the second version of Luciole. The first one was smaller but also much harder to use as a development board, and that's why this one appears. This video will be divided in two parts. The first will be a generic overview of the board and its use, and the second will be a more technical part. All these boards are natively embedded the default code that I've wrote. The program is made you to connect to the module and control the colors, light and brightness of the LEDs. You can see it as an example of the possibilities that this board creates, or just as a LED controller similar to what you can find online. The best way to power up the board is by connecting it to the 12V generic power supply. You will find a switch on the side that turns on or not the board. Please notice that the switch is only connected to the 12V power supply. It means that if you plugged the board in USB, it will power up no matter the switch position. The LED connector is a 4-pins generic one with a 12V, red, green and blue. Be careful, sometimes the order of these are not the same on LED strip or other type of RGB LED. Two solutions can be considered in this case. The first one is simply exchange the LED connector positions manually, and the second is the same but made in the software side. Once you've done that, the board will boot up and start an access point. Now you can connect to it and enter your Wi-Fi credentials. At this moment, the board will connect itself to the Wi-Fi and diffuse his web server on your network. In order to find his IP address in your local network, I invite you to download an app or use your operator web portal. Like me, you will have a peripheral name like Luciole #0001, for example, followed by an IP address. The main page of the web server looks like this. The color cycle is the classic way of changing color. To turn on the LED strip, trigger the switch below the circle. You can now set the color you want. If you like one or many colors, you can select them and click on Save in order to save it. Once you saved all your favorite colors, you can display them by clicking on it in the drop-down menu. Finally, you can find at the bottom of your screen the things called Smart Light switch. Once this option is active, the light by default will stay white during the day and then will turn orange with the sunset. The day and the night colors can be set by opening the burger menu and choosing the colors you want. Night at the top and day at the bottom. The next and also the final smart option is the alarm. This option turns the light on the color you choose gradually at the hour you've set, generally to wake you up. Before going to the other page, I recommend you to set the color you want at the very bottom left of the screen. Click OK and then go on the other page. In this page, you can set the hour you want and turn on the switch in order to activate this functionality. This hour is stored and displayed on the same page, by the way. All of that concludes the software functionalities that have been developed during few weeks. Otherwise, if you want to program the board, you can easily do it through the micro USB connector. This one can be considered as a Wemos Day1 Mini, by the way. Now I want to talk about more of the technical aspect. The board is totally open source and you can find all the additional information, schematics and code on my GitHub page. The board is made around the ESP8266. Near the 12V power supply you can find a 5V step-down voltage next to LDO that converts the 5V to 3.3V. The micro USB is obviously followed by a USB to UART circuits that can also supply the boards thanks to the LDO. Near the LED's connector there are 3 strong MOSFETs connected to 3 PWM pins of the ESP8266 that are used to display the red, green and blue colors. These MOSFETs can run tens of currents, so the side of the LEDs set you half doesn't really matter. The 12V and USB connectors are protected from reverse currents thanks to the diodes. Near the USB connector, I've also placed a fuse that prevents overcurrent from it. When I received and tested the first series of Luciole dev board, I've immediately noticed a problem that occurred at the 12V connector level. Indeed, the 12V and GND pins was reversed. In order to correct it, I've reversed the 12V and GND pins and then secure it with hot glue. So if you receive the board with some hot glue below the 12V connector, it is completely normal and be sure that the board will work correctly. Also, you have to know that all the boards have been tested entirely at least one day in real condition, but it is still possible that some of them does not work once you've received it. You can still contact me on Twitter, by mail or on my Tindie if needed. Currently, at the date of the video is out, I'm working on a LED spotlight that looks like this. It is equipped with the classic 4 pins and you can use it as a simple or decorative light. I think it's a great way to introduce you to the Luciole boards or other RGB LED projects for cheap. Or you can simply buy LED strip on Amazon, AliExpress or eBay. If you are interested by future development of the project or other little one, I invite you to follow me on Twitter. I'm really active in English at the moment, so I guarantee you great contents. For any questions, don't be afraid of asking in the comment sections.